scientist working in the NLP lab with Dr. Xu. I'm really excited to be here to share our Kamino project. We cooperate with Yale New Haven Hospital for a while. So I want to share our topic about the scalable architecture to support medical AI research using large real-world data. So in last year, in March, I think almost the people are aware that ChatGPT just released by the OpenAI. It captured all of the eyes of the world. It's not only reshape the direction of AI research, it also bring up more probability in AI innovation. Now we are standing up a new era. It seems like the world start to forward to the AI transformation. Let's get back to the 2017 when Google just released the Transformer as well as a state-of-the-art model. It's only taken less than 1 billion parameter. But when the time go over to the 2020, the ChatGPT, the GPT-3 is already over 170 parameters. So it also bring our attention. Can we just think about how to build a new computational environment to optimize the computing resource, and if we can leverage the large clinical data set in our AI research, it also can bring up more innovation in biomedicine field. So we also face many challenges to build up the computational platform. In traditional computing infrastructure, we only leverage one single node. Even we run the batch job in parallel, it's not tolerant to have a large scale management. It seems like a large language model is getting more popular. It requires significant computational power and memory. I just list down the model here. If we take an example for the 17 billion model, we may need to take over for the pre-train the model, we may need to have over 100 GPU cards, and each card may need to have 80 gigabyte memories. So it's really consuming computational resource. So we just think about, can we bring up a new cluster to aggregate the computational resource as one computational pool. And the third one is if we are hosting this platform on the hospital side, we still need to consider how to making a shareable environment, and we still need to consider the security and the compliance limitations. Yeah. Additionally, we also need to consider the data standardization. Seems like the data format is different between the EHR systems. So we want to align with the OMOP common data model to develop our data pipelines. So we expect that we can support to our research have the cross-site capability to cooperate with external partner or researchers. So here I just summarize the requirement of the computational platform need. First of all, we need to have a team-based workspace. It means once the research got the IRB approval, we could have them to build a workspace to grant the user who can access to. And we also can set a appropriate resource quota for them. And if based on this quota, they can have a computational pool, no matter the user maybe someone needs to have a large scale computation environment. They just need to cooperate with the researchers. And second, we want to minimize the data collection and preprocessing time. As we know, for the data preprocessing time, almost taking up over 80%. So if we can bring up a new web interface to allow the user, our researchers, to submit their data requests, and it will trigger our automatic ETL pipeline to help them to extract the related data set. And furthermore, we hope that we can mounting the extract data set to their workspace. So we can provide the computational probability and also mounting their target interesting data set to their environment. So the next step is, in order to support the various researchers' need, we also can design a customizable computing environment, each to include the hardware and the software parts. So for example, we could set up dynamically reshape the hardware resource to fulfill the value workload. For the software part, we also can build some like a software template. We can build the Docker image and pre-install some common package for them, so they don't need to have the pen for set up the environments. Okay, so here we just proposed the architect for the computational health platform. It may compose the 5 main components. So for the researchers, they only to take their attention on the first stage is first component is the web application. So researchers can create a team and they can make the data request. And the most important is they can build their environment from this web endpoint. So for those 3 tasks, we will break down into a message. We define the message as a protocol, and when it submits their request, it will flow into the message queue. So message queue is a queue to handle the user request, then decide it will routing to the following the task runner. So once the task runner pull down the message, it can help our researcher to, first of all, to build their namespace. One team may have one space, so we can control the resource quota by the namespace. And within this namespace, if the user not assigned to the namespace, they cannot access to. So it could also increase our security. And the second, if user want to have a interesting data set, they just need to submit their data request. We will run our ETL pipeline. Then once the pipeline finish, we will mount into their network drive. So once user just log in, they can easily to access those data. The third one is environment deployment. It means a user can select which software and hardware configuration they need. And we will, based on this requirement, to bring up, for example, we can bring up a private endpoint. User just needs to click a link. It will redirect to their virtual environment, something like Jupyter or Spark. So all of the application is based on the infrastructure called as Kubernetes. Kubernetes bring up many benefits for our operation. First one is it provides more scalability for the applications. If the loading getting high, we can just replica another instance for maybe for the test runner or web server, even the message queue level. So it's very easy to scale up or scale down based on the traffic or workloads. Okay, so I want to give a brief introduction about the message queue, why we leverage this pattern. So on the web application part, we call it a producer. So user can submit their request from this endpoint, right? So once user submit their request, it produces a message. So the message we have a well-defined, just like a protocol. It means the following task runner, no matter which developer, it got this message, it can they can develop their own language or their way to implement that, because we define the protocol here. So the data broker means it will aggregate all of the requests in this queue. Then the latest stage is our task runner. It will pull down the message and to finish those tasks. So based on the message queue, this pattern, message queue can help us to have three features. First of all is to decoupling. Second is scalability, and increase the reliabilities. So how can we have the recoupling? So just like I said, web application part, maybe we have a developer called a full stack or web developer. Then the developer only need to focus how to send the message to the message queue. They don't need to write the business logic. It means if the web developer is not very familiar with how to handle the clinical data, we could assign to the following task. For example, the test runner one, for the ETL part, maybe someone is familiar with hospital clinical data domain. Then he could be a data engineer, and he can implement by their own modules. So because we already defined the protocol, right? So on the front end part, maybe we implement by the JavaScript, but on the ETL part, they can implement by Python or Spark. So it can, easily to co-work with this platform. So another part is for the operations system level. For the computation environment, we may have an expert to coordinate and co-work with the hardware part. For example, if we want to release a new GPU on our computing farm, we need to have someone to install the driver and install some package, something like a CUDA, CUDNN, something like speed up the GPU computational packages. So we could also assign those tasks to the engineer, so it can help us to bring out some computational environment. Okay, so for the capability part, since we know test runner is consuming the task, right? So we have two ways to consuming the task. First of all, is we can bring up a persistence environment, something like EC2, or you can have your own virtual machine. But for the if we just need to have a temporal job, something like if we just trigger a ETL job, we just need to bring up a serverless job, something like if we leverage AWS, we will call it a Lambda job. Once it finishes, we will close this machine. So you will, to reduce our cost. Yeah, so also in other words, if we got more workload, we just need to bring out more machine here so it can consume it together. Okay, for the reliability is we also can check if some computing node on our test runner is failed. We can rerun or to check, have a health check. If this node getting failed, we can assign to another one. Okay, so it also can improve our reliabilities. Okay, so we just have introduced for the upper part. So I want to share more experience about the core infrastructure for the Kubernetes part. So Kubernetes also can ensure the high availability. It means if some instance just broken, it can automatically to restart the Docker again. So it means it will continue to check the instance of the on our machine and sync the status back to the Kubernetes. So we don't need to pay attention to double check if this environment is work or not. So it also support the scheduling. It means we can, if we want to create a new pod, new container, or we could say we want to bring up a new machine, virtual machine, we could just rescheduling from the Kubernetes. You will check which computation node is available, have enough resource. Okay, the final thing is about the security and the namespace actually is isolate. So once we create a new team, it have their own namespace. So only this namespace user can see the sensitive data. So it help us maintain the secure environment for the application running on the Kubernetes. So here, how the Kubernetes work, basically it contain the 4 parts. So for the one cluster may have the one API server, and API server is means if you want to create the environment or you want to have create some service, you just need to call the API server. We could do the UI or API, even the CLI tool to communicate with the API server. Okay, so once you submit API request, then the controller manager will get this request. So you will check back to our cluster. Then here we call a term is etcd. So it will store the machine status. Then the scheduler will check if someone just submit a new request, you will make the scheduler to scheduling which node is available, have a which computing node have the resource. Okay. So here is a life cycle. API server part is for the action, and the etcd just store the status. Scheduling is help you to review the new request, how you will forward to. So for each node has the agent to, if you gather request, you will start to do the task. Okay, for example, here it will help you to running the Docker to build your part. Okay, so actually, if we want to bring up a computational environment, it's really time consuming and it's really complicated. I don't want to pay more time on this one. We just need to know if When we leverage the Kubernetes, it will help us handle the network part. It means even we need to communicate with different part of our service, it will handle that through this ingress over service. If we want to scale up, if the computational environment is not, the resource is not enough to serving our workload, you just need to scale up from the stateful set. So it will help you to deploy the instance by order, and guarantee it will successfully to deploy on our Kubernetes. Okay, the final part is about the storage. So we can claim what kind of the storage class we can provide. Some tasks may need to high read capability. Some is more focused on writing, right? So we can define what kind of the storage we have. Then the final one is if user need to push label, we just define the storage. We can just claim which one you need. Okay. So for now, I just want to have a practical example for our AI research. How can we submit a data request? And the second is how can we create a new computational environment? So how can submit a data request? First of all is we need to select the cohort. So how to define the cohort? First of all, you can provide your MRN. So based on the YNHH, they have the identifier. We also call the MRN is unique. If you provide your target MRN, we could help you to build the cohort. And if you also can list down the MRNs as a list and upload to our platform, we could also help you to matching those patients. The most popular part is using our predefined cohort. So for example, if we select a COVID-19 patient, positive patients, then here, if you select to your cohort, it will display some demographic. First of all, is the visit by year. How many patients visit by year? And second is the age distribution. Also have the gender distribution, and the last one is your this cohort medical histories. So you can if you want to choose this one as your target cohort, then the second step is you can select which dimension you want to mapping. Basically here we just mapping to the OMOP data model. For example, most people always choose patient, right? Because patient is the basic information you can link it to different dimension. So for example, if you want to select a specific diagnosis, you just need to pick up the condition or occurrence. Then you could key in what kind of the diagnosis you want to retrieval. It basically, we enhance this feature by the electric search, and we order by the frequency. So once you got the record on the top, it means you the most user have these records. Okay, so once you selected your target dimension, and you can review your data request. Then if you submit, our service team will receive your request, and to review your request is under your IRB. If everything work okay, it will trigger our ETL pipeline. Okay, so And the second task that we want to introduce how to create a computational environment. So it's very simple, just need to rename the environment, and you can select the hardware and the software part. For the hardware part, you could select here. I just list down some is GPU, CPU only, someone is GPU only. So if you running some small job, you just need to pick up the in the phone. But if you have a work heavily job, you could select some like a GPU specific configurations. Okay, then we also support many the software stacks. So I will introduce later. So once you pick up the software and the hardware part, the next stage is you can also bring up your data set, because we already submit our data request, right? So once you finish, you will have a name for your data request. You just need to type in which data set you want to mount in to the virtual environment. Okay, so once everything you set up finish, you will bring up environments like this one. So here just have an active session. It just listing the endpoints. If you click it, it will redirect to the Jupyter Notebook. So on this Jupyter Notebook, here just listing some folder. First one is for the team folder. Is support to read and write. All of the user under your teams, they can read and write any file under this directory. And the second one is data folder. If we request the data, if we submit a data request, we will mounting your data set in this folder. It's read only, so no one can rewrite this one. Okay, so currently on the environment, we support many languages. First of all, the most popular is Python. We also support R and Julia. So you can choose which one you are prepared to. Okay, so the results. In the YNHH, we already aggregate over 12 billion records on our database. It also facilitates for our research studies. Our platform also aggregates the data set from the patient monitor device, which it means the data device every day it will generate over 700 million records. So it means our architect can support the stress to get everything work daily. So it also successfully to support various bioinformatic AI research and generate the real world evidence. For example, for this one, we can leverage this platform to build up a COVID-19 severity level classification. And second one, this publication is for we could on the COVID-19 duration. I think to think of the real-time data is really important, right? So leverage this platform, we can sync the latest record to our platform. And in the first stage, we could notify on the front end part, maybe from forward this notification to the doctor or the employees on the hospitals. Yeah, also leverage this platform, we could have a data discovery. So yeah, this platform also have some ongoing projects. This one is for the annotations. we could install the annotation tool on our Kamino platform. This one is an example for the label studio. User can label their data set on our platform. So, for example, here, if you want to labeling the disease for the eyes, you just select which inch area you need and label the the data. Yeah, and the second, we also have a second integrated project is for the large language model. So user can without to writing any code to submit their fine-tuning job through this endpoint. They just need to select what kind of the model they need and check which data set you want to run and then set up some configuration for this job. Then it will help you to evaluate the fine-tune result. Okay, the final one is for our developing application. We call it Kiwi. We already released a model based on the Llama 2 to help user to gather result from the clinical note. We could help you to recognize which belong to which property and help you to extract the relationship based on our tools. So you just need to paste or upload your clinical data here. We just help you to visualize interface here to understand the relationship and the entity. Okay, so we hope we could build up the loop. User can from the beginning, they can annotation the data from our platform. Then second, you could training your data, even you could fine-tuning your model. The third stage, you can evaluate the model accuracy by our tool. Final, if you finalize your model, we could host your AI application on the Kubernetes, and it will handle the tons of things, something like set up the load balance or have you have a self-healing capability. So yeah, we hope we can build up this ecosystem, and if you are interested, please welcome to using our Kamino. So here I just list down the four steps. So you can submit your data, your service request to create a YHH account, and you need to sign up a DUA for the chip environment. So the PI can submit your application to those three emails. If you have any question, you could connect to the Alex. It will help you to introduce the whole workflow. Okay, so final, if you need to connect it to the YHH, you may need to have a VPN. You can submit a ticket through the ITS. I just listing the URL here. The final, just enjoying our Kamino, just logging through this URL. Okay, that's all for my presentation. Thank you.
I think today's platform is running and will provide a lot of service to our YHH and both and the YSM community. A lot of our faculties and the researchers will are using this one. So do you have any questions you want to ask? So maybe I have one for this one. So can we support like R Studio or any similar software in this platform? I see we have some Jupyter Notebook and other R, but it's integrated with the Jupyter Notebook.
Yeah.
Can we support like R Studio, those kind of different IDE?
Yeah. Currently, we haven't support R Studios, But based on our design, we could build the Docker image for the RStudio. Then once we do configuration, how to set up the RStudio, we could bring up the RStudio environment. Yeah.
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 Basically, it can support different software. It's like maybe for other like other programming language, they can also support.
Yeah.
Like in YCRC, we also support the VS Code server.
Oh.
So maybe we can also support that as well.
Yeah. Actually, if user is familiar to SSH terminal, maybe they can here. Sorry. We also provided the connection through the SSH. So yeah, here, if user familiar with the Linux console, they just need to follow this command to access to the environment. If a user like use VS Code, you also can leverage this command. So you could using VS Code to write your script. You don't need to have the GUI part to open up the browser.
How I get some as part of my medical school. I'm going to Japan. Thank you.
Hi.
Hello. Could you repeat your question again?
I think the annotation part is really what's your time frame to support?
Yeah, it's a good question. Currently, it already already running on our local sites. Yeah, so if we want to have this template start to service to our research, I think we may have a senior engineer coming. We will help us to build that environment. Yeah. Yeah.
Yeah. So basically, when you build a new image, we include that software in that image with forms, reports, and other things to access. But I think it's visible, but definitely the photo here.
Is there any log system log the usage of the
You mean log system? Oh, yeah. Actually, Kubernetes is building the monitor dashboard. Kubernetes will do some health check, so it will read some like a GPU usage and memory usage. We could, yeah, if you need to trace your memory and the CPU usage, you can just using Kubernetes dashboard. But currently, we didn't provide to the end user. For our service team, we can see the each of the instance, the behaviors. Yeah, but it's a good question. I got some feedback from the researchers. Sometimes, if we training a big model, it may take a large of memory. My suggestion is from the end user part, they need the best practice is you could writing the login info, something like before the function and after the function, you can recording to logging the memory usage. So you can find out which part may take a peak memory.
There are building system and the payment system for that. Right now, I don't.
Yeah.
Free, right?
Yeah, currently it's free. Yeah. If you have the difficulty to get the records, I mean for the research record, you can reach out our service team. We can share the resource usage history for you. Yeah. Thank you.
Currently, I think all the services is free, so we don't have. Charge all the-
We haven't charged, but we start to planning a price model. I'm not sure when we will start to charge the researchers.
I guess we can leave that question to leadership.
So now is a good timing if you want to have a playground. Welcome to apply the account.
If any question online,
Okay. Mm.
like. Yeah, so any questions from online people? It seems no. Okay.
Okay.
We can quite a bit. Thank you so much for joining this call. For seeing more action actually.
Thank you.
Yeah.